units. The first unit is in 4 sections, so let's kick off with nutrition and the digestive system. We humans need 5 different food types, and they're all essential for healthy life. And in this country, they're relatively easy for us to get hold of. But what if you have to take everything with you for several months? Then it requires some careful thought. In this next clip, make a note of all the different food types that are mentioned.
So, we've all got to eat. But what if you're at sea? You only get to eat what you've remembered to bring. That's true of the people I've come to meet. They're about to start off on a yacht race around the world, and I have brought them some supplies.
The crew are certainly going to need to eat healthily, and they've had to think carefully about the food they're taking on the trip.
The nutrients our body need could be put into groups. Carbohydrates, proteins, fats, and of course vitamins and minerals. Carbohydrates provide readily available energy, and we need a lot of carbohydrates. We use up a lot of energy sailing, so we have to eat twice as much as we do on shore.
But the trouble is, the food rich in carbohydrates that I've brought the crew are either too heavy, too bulky, or would go stale. Almost all the crew's food is freeze-dried, from fruit and yoghurt to their omelettes, and even this stroganoff. The meat in this provides a source for another nutrient, protein, which is vital for our cells to grow and to help build new cells. The crew are going to be sailing close to the Antarctic, and there the cold will mean they'll be relying on their body fat to keep warm. Fats are found in foods like biscuits and butter. Fats are a good source of energy, releasing energy more slowly than carbohydrates.
Well, it's not bad. Can you get everything you need for a healthy diet from this freeze-dried food?
Not quite. We need a lot of different vitamins and minerals. They do different jobs in the body. They're usually in a balanced diet, but when food is freeze-dried, it's destroyed.
Fresh fruit and vegetables are the best source of vitamins and minerals, but what I've brought would perish and is still too heavy.
So we have to have all our vitamins in a tablet form like this.
But I'd rather eat fresh food any day.
But we're prepared to do this to win the race.
So, have a go at writing the different food types down. You should have come up with 5 different food types: carbohydrates, proteins, fats, vitamins and minerals. The other 2 things that you need for a healthy diet are fibre and water. Not technically food, but still essential for a balanced diet. And together with the 5 different food types, they make up the 7 components of a balanced diet. For your test, you should know the 7 components of food and what we use them for. Carbohydrates are used for readily available energy. Proteins for growth and repair. Fats are a supply of stored energy and insulation. Vitamins and minerals we need in tiny quantities for cell chemistry, and minerals for healthy blood, bones and teeth. Fibre, roughage, is the indigestible part of food, but aids digestion and helps prevent bowel cancer. And last, but by no means least, water, which is essential for life, and we need lots of it to replace all that is lost through excretion and respiration. But to turn this list into soluble substances that the body can use, the process of digestion needs to get to work.
She might not realise it, but her investigations have just started. She's taking the first steps in breaking down of her food. The mouth is like a chopping board. Well, it is. The teeth chop up the food and grind it to a pulp. It's a very physical process. Chewing also increases the surface area of the food, which helps the first chemical processes of digestion. And that's where saliva comes in. Wonderful stuff, saliva. Food's got to be broken down chemically so that the large molecules of food can be changed into molecules small enough to be absorbed by the body. Saliva contains an enzyme which starts breaking down the starch in the bread and chips into sugars the body can actually use. There's still more breaking down, more digesting to do. Once the food reaches the stomach, glands in the stomach lining secretes a liquid called the gastric juice, which helps break down protein. Everything's mixed together and churned up by the muscles in the stomach wall. A lot of the carbohydrates and some of the protein have been broken down, but hardly any of the fat from the food's been digested yet.
Can I eat another thing?
So, now the food's in my stomach, the proteins and carbohydrates are breaking down. But what's next?
Well, it all moves on to the small intestines.
Ah, the duodenum. What happens there?
This is where the fats in the burger are broken down. Bile, which is made in the liver, together with enzyme, this time from the pancreas, break down the fats. These enzymes from the pancreas complete the digestion of the rest of the carbohydrates and the proteins too.
So, in the duodenum, fats are dispersed into tiny droplets. Carbohydrates and proteins are digested here too.
All the nutrients from your digested foods passes through the walls of the ileum to get into your bloodstream. This means at last the body can actually make use of the nutrients. By the end of the small intestines, nearly all the nutrients from the food have been absorbed into the blood system.
So, by the time the foods pass through the ileum, they're broken down enough for the nutrients to be absorbed into the blood.
And it's on to the last stage of digestion.
The large intestine. But what's actually left by now?
All that's left is a little water and undigested food. Fibre, for instance, which helps to keep the feces moist. So there's not much of Femi's burger left. A little bit of water which has been absorbed through the walls of the large intestines. The remaining material, the feces, becomes a little bit more solid. And that passes out of the body through the anus.
So, there you have it, the complete digestive process of a hamburger, described by Rusty the chef. Perhaps I'll eat it later. You need to remember that the point of digestion is to break down our food into simpler substances that the body is then able to use. So the question is, what are the different ways in which food is broken down? Well, there's certainly more than one. Stop the tape if you want to work out your answer. Your answer should include 2 points, that food is broken down both mechanically and chemically, and that the saliva in the mouth and gastric juices in the stomach produce enzymes that chemically help break down the food into smaller molecules. Remember, digestion is the process where complicated food substances are broken down into simpler, soluble foods which can be used by the body. That's it for nutrition and digestion. But if you weren't sure of any of the facts, then why not rewind to the beginning of this section and look through it again? Or you can go straight on. Our skeletal system consists of bones and other soft tissues that hold us together. Without a skeleton, we would be very floppy indeed. But support is only one of its 3 functions. It also protects vital organs such as the brain, heart and lungs. And its 3rd function is for movement. The skeleton has different types of joints: the vertebra, ball and socket joints, and hinge joints. So let's check through the key points you need to remember about joints. Joints are points in the skeleton where two or more bones meet, and there are three types of joints you should know about. The hinge joints at the knee and elbow, ball and socket joints at the hip and shoulder, and partly movable joints between the breastplate and the ribs and between the vertebrae. But how do joints help us to move, or do anything for that matter? Pick up a drink, that's my hinge joint. And to jump off this bench, or jog on the spot, I'm using all the different joints. But just how do they work?
Looking inside a running knee joint, the muscles that cause movement are attached to bones. They're called skeletal muscles. So it's skeletal muscles that move your body, and they work in pairs.
Now you can feel two of these working together when you bend and straighten your arm.
You can see it with this model. To bend your arm, the biceps contracts. It gets shorter. You can see it bulge and harden. The triceps relaxes. As a result, the biceps pulls the bones together and the arm bends. To straighten your arm, the opposite happens. The triceps contracts and the biceps relaxes. This pulls the bones straight. Muscles can only contract and pull bones, never push them.
So now some facts about movement you really need to know. Muscles can only contract. They shorten and then relax, go back to their original length. Muscles usually work in pairs, having an opposite effect on each other. They are described as antagonistic muscles. Respiration and breathing are two processes that can be confusing. So let's sort out what we mean by those terms. For a start, they are very different. Let's look at respiration first. To continue cycling, let alone do anything else here, I need energy. And where do I get my energy from? I need a supply of oxygen to release the energy from the food I have eaten. And as a result of a series of chemical reactions, complex molecules are broken down into simpler ones. And in the process, energy is released. Now that is respiration. Breathing, using my lungs, is simply how I get the oxygen into my body. Whew, it's hard work, this. Okay, here are some definitions. First of all, respiration is aerobic. Aerobic means with oxygen. And aerobic respiration is the process by which living organisms use oxygen to release energy by breaking down complex molecules into simpler ones. So remember, in respiration, oxygen is used to release energy. Breathing is just the process that allows oxygen into our bodies. Now we've got that sorted out, let's take a closer look at the process of respiration.
I thought we got our energy from food.
Well, food is an energy store, and carbohydrate is one of the best stores of energy. But it's not enough just to eat the food. We need also to release that energy to take in a gas from the air that we breathe.
Air is a mixture of different gases. It's mainly nitrogen and oxygen, with a very small amount of carbon dioxide. But which one of these gases do we need?
We can test to see what gas our bodies need by looking at the difference in the gases that we breathe in and the gases that we breathe out. As we know that the air around us is 21% of oxygen and only 0.03% of carbon dioxide. And if you'd like to pop the mask on, we'll have a look at the gas that you breathe out.
When I breathe out, the air only contains 15% oxygen, not as before.
Well, that's a lot less than I inhaled, so I must have used up some of the oxygen when I breathed.
That's right. If you'd like to pop the mask back on, we'll have a look at the carbon dioxide that you breathe out.
Only 0.03% of the air I breathed in was carbon dioxide, but when I breathe out, that has increased to 5%.
That's over 160 times more carbon dioxide than the air you breathed in.
That's amazing.
And look, If you'd like to take hold of that and breathe out, you'll see another byproduct of the process. Water.
So, I used up oxygen and produced carbon dioxide and water.
And energy.
Respiration is a chemical reaction which releases the energy we need. The carbohydrates in our food react with the oxygen from the air. This produces carbon dioxide, water, and most importantly, energy.
Let's have another look at that equation, as it's vital for your test that you understand it and know it off by heart. Glucose and oxygen produce energy and carbon dioxide and water. Why not stop the tape and try writing it out from memory? So far, we have seen how oxygen is used to release energy. But how does the oxygen reach the cells and tissues in the first place?
Air goes down your throat through a pipe called the trachea, which branches into two bronchi, one bronchus into each of the two lungs. These in turn branch into a network of smaller tubes called bronchioles. Oxygen is absorbed into the blood and carbon dioxide passes out in the air sacs.
You need to know the structure and function of our lungs. So if we're going to draw a sketch of our lungs, we would need to include the trachea dividing into the two bronchi. Inside each lung, the bronchus divides into many bronchioles, and at the end of the bronchioles are air sacs called alveoli. The question is, how are our lungs adapted to gas exchange? By expanding and contracting, our lungs are able to take in oxygen and breathe out carbon dioxide. But as we've seen in the clips, they have some other special features. If you like, you can stop the tape and have a go at answering the question. So, how are the lungs adapted for gas exchange? Your answer could include 4 different points. 1, they have a huge surface area. 2, a massive blood supply. 3, they have a moist surface. And 4, they have very thin walls, only 1 cell thick. So far, for humans as organisms, we've looked at digestion and nutrition, movement, respiration and breathing. Now, if you weren't sure of any of these subjects, then you could rewind the tape and go back over them. Here are a few tips for remembering all those facts.
Find somewhere quiet to revise. Maybe in your room, somewhere where you can sit down, spread out your work before you. Make sure you don't have any distractions. No television, no radio, no magazines within view, so it's just you and your books.
Don't panic about your test because it will probably just make you more nervous when you come to sit them, and just try your best.
Just relax because the week goes really quickly, and if you worry too much about them then you won't do as well as you can.
I think you should have a quiet room to revise, so turn all distractions like TV and stereo off, because it takes longer to revise and you don't take it in as well.
Eat a sweet before the exam because it will calm you down much more.
That brings us to the end of this unit, and it would be a good place to take a break. Or you could go straight on to the second unit of Humans as Organisms. Don't forget the Key Stage 3 bite-sized book and the website have lots of info, diagrams and interactive questions on these subjects.
And of course vitamins and minerals. Carbohydrates provide readily available energy, and we need a lot of carbohydrates. We use up a lot of energy sailing, so we have to eat twice as much as we do on shore.
But the trouble is, the food rich in carbohydrates that I brought the crew are either too heavy, too bulky, or would go stale. Almost all the crew's food is freeze-dried, from fruit and yoghurt to their omelettes, and even this stroganoff. The meat in this provides a source for another nutrient, protein, which is vital for our cells to grow and to help
units. The first unit is in 4 sections, so let's kick off with nutrition and the digestive system. We humans need 5 different food types, and they're all essential for healthy life. And in this country, they're relatively easy for us to get hold of. But what if you have to take everything with you for several months?
And vegetables are the best source of vitamins and minerals, but what I've brought would perish and is still too heavy.
So we had to have all our vitamins in a tablet form like this.
I'd rather eat fresh food any day.
But we're prepared to do this to win the race.
So, have a go at writing the different food types down. You should have come up with 5 different food types: carbohydrates, proteins, fats, vitamins and minerals. The other 2 things that you need for a healthy diet are fibre and water. Months. Then it requires some careful thought. In this next clip, make a note of all the different food types that are mentioned.
So we've all got to eat. But what if you're at sea? You only get to eat what you've remembered to bring. That's true of the people I've come to meet. They're about to start off on a yacht race around the world, and I have brought them some supplies.
The crew are certainly going to need to eat healthily, and they've had to think carefully about the food they're taking on the trip.
The nutrients our body need could be put into groups. Carbohydrates, proteins, fats.
Help build new cells. The crew are going to be sailing close to the Antarctic, and there the cold will mean they'll be relying on their body fat to keep warm. Fats are found in foods like biscuits and butter. Fats are a good source of energy, releasing energy more slowly than carbohydrates.
Well, it's not bad. Can you get everything you need for a healthy diet from this freeze-dried food?
Not quite. We need a lot of different vitamins and minerals. They do different jobs in the body. They're usually in a balanced diet, but when food is freeze-dried, it's destroyed.
Fresh fruit